So in the last video, we were looking at linear modeling by creating the graph, whereas here, the other part of linear modeling is when you're given a graph and asked to interpret information from it. So in this case, Alex was 200 meters from his house and he decided to walk to the shops. This graph here shows his distance from his house at various times on his 5-minute walk. So distance is represented by d, and that's our y-axis, and time in minutes is represented by t, and that's on our x-axis. Now, the first part of the question is asking us, how far away from home is he after 5 minutes? So what we do is we go over to the graph, we go to 5 minutes, we go up here, find out where it is, and go across to read the value of the y-axis. We can see the answer is he's 800 meters from home. Simple. Part B is asking us, how far did he walk in 5 minutes? Now, we need to be careful here because the graph does not cross at 0 here, does not cross the y-axis at 0, which means that even though he was 800 meters from home after 5 minutes, that's not how far he walked. So we know between 0 and 5 minutes, he walked from 200 to 800 meters, and then that's just simple arithmetic, 800 minus 200, you walked 600 meters in those 5 minutes. Part C then asks us to calculate the gradient of the graph. Now, we know 2 points on it because we worked out that after 5 minutes, he's 800 meters away from home. So that's obviously going to be 1 point that we could use. It'll be 5, 800. And the other point we can use is our y-intercept. So there we know that's 0, 200. So we'll call this one 0.2 and this one 0.1. Our gradient calculation, as always, y2 minus y1 over x2 minus x1, which is going to be 800 minus 200 divided by 5 minus 0. 800 minus 200, we know is 600, divided by 5, and that should equal 120. So our gradient is 120. Part D asks us, what was his speed? Now, speed and gradient are actually the same thing because speed is just distance divided by time. And if we look back, when we calculated the gradient here, the top part was distance, the bottom part was time. So distance divided by time was 120. That means we just need to put his speed into a more common usage. So we can say his speed was 120, and we can see the units are meters and minutes. Therefore, he was walking, where's my mouse gone? 120 meters per minute. Simple. And finally, it's asking us to write the equation represented by that graph. Now, obviously, we know general form of an equation is going to be y equals mx plus c. In this case, our y is actually d, and our x is actually t, because we've got distance and time. So we know our gradient was 120. And if we go back up, we can see that our y-intercept was 200. So that was something we knew. Therefore, our value for c is going to be 200. So then we take these values and we substitute them into that, which means our final equation ends up as d equals 120 t plus 200. That's easy. And if you wrote out y equals 120x plus 200, and that's what you put in the calculator, that would be the exact same thing. It's the same graph, we're just using different variables to represent the same things.